Have you ever wondered how to build a machine learning model from scratch? In this video, I'll guide you step by step to create a simple yet powerful machine learning model using Scikit-Learn. Whether you're a beginner or just need a refresher, this is the perfect place to start. The first obvious question is, what is a machine learning model? A machine learning (ML) model is a mathematical representation of a real-world process. It is trained to recognize patterns, make decisions, or predict outcomes based on input data. It serves as the core of any machine learning system, enabling computers to learn from data without being explicitly programmed. How an ML model works. Input data. Data is provided to the model, either structured like tables or unstructured like images or text. Two, training. The model is trained on this data using algorithms to find patterns or relationships. Three, output. The model makes predictions or decisions based on new, unseen data. Key concepts of ML models. Features. The inputs used to make predictions, example, age, income, or pixels in an image. Labels. The expected outputs or ground truth, example, spam or not spam for an email. Training data. A dataset used to teach the model how to perform a specific task. Testing data. A separate dataset used to evaluate the model's performance. Let's discuss a simple example of understanding ML model. How to derive a mathematical model from X and Y values. Given a dataset with X, input, and Y, output, values, we aim to find the best fit mathematical function of X that explains the relationship between them. If data has a linear relationship, it can be represented by a linear equation y equals mx plus c, where m is the slope representing rate of change, and c is the intercept, that is value of y when x equals 0. to determine, and we use least squares regression. Step 1. Calculate the slope using this formula. Here x bar and y bar are mean or average of x and y values. Step 2. Calculate the intercept. Equals bar minus slope m multiplied by bar. Let's consider a sample dataset with x and y values as shown to obtain a mathematical model. One. Calculate the mean of x and y required by the formula as discussed. Here we obtain mean of x is 3 and that of y is 9. 2. Calculate the slope m using the formula as shown and discussed. Slope is calculated as 2. 3. To calculate the intercept c. Intercept c is calculated as follows. Its value is 3. The model is f of x is y equals 2x plus 3. If the relationship is not linear, you might fit a polynomial, exponential, or logarithmic function. The general form of polynomial. Use methods like polynomial regression for any model f of coefficients. Define the error or loss as the difference between predicted and actual y values. Minimizing e example. Using calculus or iterative optimization provides the best fit parameters. The calculation done can be implemented by writing a Python program using numerical Python library as shown in the code on screen. For number py, please refer to my previous video. Examples of ML models. Linear regression. Predicts continuous values like prices or temperatures. Decision trees. Classifies data into categories. Neural networks. Mimics the human brain for complex tasks like image or speech recognition. Scikit-Learn Overview. Scikit-Learn, commonly abbreviated as Sklearn. It is a free, open-source library for machine learning built on top of Python. It is a cornerstone tool in data science and machine learning due to its simplicity, efficiency, and flexibility. Key features of Scikit-Learn. Wide range of machine learning algorithms. Supervised learning, linear regression, logistic regression, decision trees, support vector machines, etc. Unsupervised learning. Clustering, k-means, discan, PCA, and more. Preprocessing tools. Data scaling, standard scaler, min-max scaler. Encoding categorical variables. One-hot encoder, label encoder. Handling missing data, simple imputer, can-in imputer. Key features of Scikit-Learn. Model selection and evaluation. Splitting datasets, train_test_split. Cross-validation, cross_val_score. Metrics, accuracy, precision, recall, F1 score, and more. Integration with other libraries. Works seamlessly with NumPy, Pandas, and Matplotlib. Basic workflow with Scikit-Learn. Data loading. Use datasets from Scikit-Learn.datasets or load your own. Preprocessing. Clean and preprocess data using scalers, encoders, and imputers. Splitting data. Split data into training and testing subsets using train_test_split. Model training. Choose an algorithm, example, random forest classifier, and fit the model. Prediction and evaluation. Make predictions and evaluate model performance using metrics like accuracy or F1 score. Data loading. Use datasets from Scikit-Learn.datasets or load your own. We'll use the famous Iris dataset, which is built into Scikit-Learn. Let's load it and take a quick look at the data. From Scikit-Learn.datasets, import load_iris. Before actually moving to development and testing the concepts, let's discuss Iris dataset. The iris dataset is one of the most famous and frequently used datasets in machine learning and statistics. It is often used as an introductory dataset for classification problems. It is available in Scikit-Learn as a built-in dataset. Published by Ronald A. Fisher in 1936. Type: multi-class classification problem. Purpose: to classify iris flowers into one of 3 species based on 4 features. Iris dataset, dataset structure. Features, input variables. The dataset includes 4 features. All are continuous numerical values. One, sepal length in cm. 2, sepal width in cm. 3, petal length in cm. 4, petal width in cm. These features represent the physical dimensions of the iris flowers. Target output variable. The target variable is the species of the iris flower. There are 3 classes. 1. Setosa, label 0. 2. Versicolor, label 1. 3. Virginica, label 2. Dataset characteristics. Total samples, 150. Number of classes, 3. Each class has 50 samples. Balanced dataset. Each class has the same number of samples. No missing values. The dataset is clean and ready for use without pre-processing. No missing values. The dataset is clean and ready for use without pre-processing. In this video, I'll guide you step by step to create a simple yet powerful machine learning model using Scikit-Learn. Whether you're a beginner or just need a refresher, this is the perfect place to start. Recall, the Python package manager command pip will be first to install the library Scikit-Learn. Recall our earlier projects developed will be reused in Visual Code to demonstrate ML model building with Scikit-Learn. Let's launch Visual Studio Code. The first task is to activate the virtual environment created for the last project using Terminal window. Here is the command to activate the virtual environment. As can be seen, that the virtual environment is activated. Now, let's install Scikit library using pip command. Wow, the library is installed successfully. This code can be used to check whether Scikit-Learn library is installed or not. We'll use the famous Iris dataset, which is built into Scikit-Learn. Let's load it and take a quick look at the data. Here is the Python code to load Iris dataset provided by Scikit-Learn library. It will be used to load and print Iris data to visualize the data of this dataset. Let's create the new Python file skl.py to test the code to load and test Iris dataset. The copied code is pasted in the skl.py file. This command loads the load_iris function from the library. These are the sample datasets available in Scikit-Learn library that can be used in place of Iris dataset, depending upon your requirement. For now, we focus on Iris dataset. Data frame is created with the features, inputs, of the Iris datasets, and also the labels as output. Make sure to save the file. Let's run and test the developed code. As you can see, the dataset contains 4 features, like sepal length and petal width, and a target column indicating the flower species. The head function displays first few records from the dataset. The relationship between features can be plotted as a graph using matplotlib. If you're not familiar with it, please my video related to it. This code plots the relationship between features of the iris datasets. Let's paste the copied code in the Python file. Save it, run, and test it for the relationship between features, input of the iris dataset. Showing error on Seaborn indicates that it is not installed. So, let's install it with the Python installment manager command pip. The pip command on successful execution installs the Seaborn library in the virtual environment as can seen in the terminal window. Show function displays the graph. Let's now save and test the developed code. The graph display shows relationship between features. We can visualize the dataset using a pair plot. Features represent the physical dimensions of the iris flowers. The target variable is the species of the iris flower. There are 3 classes. 1. Setosa, label 0. 2. Versicolor, label 1. 3. Virginica, label 2. The dataset includes 4 features. All are continuous numerical values. 1. Sepal length in cm. 2. Sepal width in cm. 3. Petal length in cm. 4. Petal width in cm. Now, guys, you have become familiar with the iris dataset available with Scikit-Learn library. Let's try to use this dataset for building ML model. 1. Load dataset. As you can see, the dataset contains 4 features, like sepal length and petal width, and a target column indicating the flower species. 2. Preprocessing the data. Before we train our model, we need to preprocess the data. This ensures all features are on the same scale, which helps our model perform better. Here, we're using the standard scaler to standardize our feature values. Now, let's split the data into training and testing sets. This ensures our model is evaluated on unseen data for a fair assessment. We're using 70% of the data for training and 30% for testing. For training the model, time to train our machine learning model. We'll use a random forest classifier, a versatile and powerful algorithm. In just 2 lines, we've trained our model on the iris dataset. 5. Evaluating the model. Finally, let's evaluate how well our model performs on the testing data using accuracy as our metric. Let's copy this developed code and paste in our project in Visual Code. Here we take a separate Python file to paste and then test the code. The developed code is as per the steps to build ML model. Python code to predict the outcome and also to evaluate the developed ML model for accuracy. Save and test the code. Here are the predictions from the trained model. It also displays the model accuracy. This sample Python code demonstrates the ML model building with Scikit-Learn, training model, evaluating, and predicting the result. This code displays some records of the dataset as can be seen on the screen. Recall and recap all that we have learned in this video tutorial. Starting basic of ML model, installing Scikit-Learn library, and using it to test the trained model and also evaluates its performance. Recall splitting datasets into training and testing records. Let's deactivate the virtual environment. Applications of Scikit-Learn. Predictive analytics. Predict future trends based on historical data. Natural language processing. Text classification, spam detection, sentiment analysis. Image recognition. Handwriting recognition, face detection. Customer insights, customer segmentation, recommendation systems. Healthcare, disease prediction, patient clustering. Let's recap. Today, we learned how to load and pre-process a dataset, split data for training and testing, train and evaluate a machine learning model. Thanks for watching the video. Don't forget to subscribe my channel. Comment your queries and doubts in session. Guys, please like and share my video and subscribe to my channel.